All right, so now figure out what it's looking for. Look at that review sheet that I gave you. The not only the words, but the formula sheet. Because you get that formula sheet on your test. So you're in confidence interval section. You need to find out the sample size. Sample is n. So you only have two formulas. This formula and one that deals with p hat, q hat. Does this have a p hat, q hat in it? No, this has a standard deviation in it. So that's the only possible formula you can use that says n equal under confidence intervals. So you're going to put this information in. This is your margin of error. Usually wherever it says within, that's your margin of error. And you're going to calculate what your sample size should be. And you need to round up. Make sure you round up. There is no formula sample size for a t-score. Okay. 21. I did tell you use the t-distribution. However, even if I didn't tell you that, you have a set of data. There's 10 pieces of data. It says find the sample mean. Find the sample standard deviation. Is there anywhere that I gave you the population standard deviation? No. So under your confidence interval formula sheet, you have one for z-scores, it's the population standard deviation. You have one for t, it's the sample standard deviation. So even if I didn't tell you this part right here, you would know to use the t-score because there is no population standard deviation. There's only a sample standard deviation that I had to find. This goes in your L1. Make sure you pull out your SFs, not your population standard deviation. Calculate your margin of error. How do I find TC? You can make the graph. This is T. Table 5. And doesn't table 5 right across the top say level of confidence? You don't have to subtract anything, add anything. Level of confidence, come all the way down. Find your N, subtract 1, get your degrees of freedom. So find your TC. Your table 5 is quite nice. Don't use inverse norm on this because it's not a C-score, it's a T-score. Use table 5. I will give you the tables. I will give you the tables tomorrow, and I will give you your formula sheet.
Tomorrow's multiple choice?
Tomorrow's multiple choice and the hypothesis test. Find the claim, test it.
Oh.
Fail to reject HO, reject HO.
Oh, okay.
Easy. That's the one we did last, so I hooked that in with your multiple choice. I will tell you, last year, the kids had the old time. So 33 minutes, and you have 45 minutes to take the same amount of work.
Are those going to be up tomorrow?
Yes, but it's also in a little packet with your formula sheet. It's also in there.
So this is the exact packet we're getting after the 5
Yes. Yes. Okay. Now, you can also use your calculator for this. I do not have a problem you using the calculator. Stat, test. I like the calculator for the intervals. It's my favorite one to do the intervals and the hypothesis testing, of course. But here we are at all the intervals right here. Pull the intervals up to the top. It's got to say the word interval or INT. So there was my Z. Here is my T. So it tells you exactly that. You do not have a population standard deviation. You have an X, which you found from your sample stuff. You could even leave it in data if you put it in your L1. It'll figure out all these things for you. 3.38. N is 10. Not degrees of freedom, N. 90. And calculate. Make sure you tell me calculator. Make sure you tell me what step. Again, I'm not grading this. So if you just put an answer down, you get no credit for it. I'm not the one grading this.
We don't need credit. We don't need work on the multiple choice.
No, but there's some you should work out. You're gonna have to work out. But all we do is check the multiple choice answers.
Okay. And how many points is that out of the total?
I don't even know. It says it on the thing tomorrow. It's not even. It's probably a third of your test.
Huh. What's on the test on Wednesday?
Wednesday is going to be something like this: confidence intervals, graphs, something with z-scores, whatever else we did in between. Hypothesis I kept separate because it's kind of like a little animal within itself, so I hooked that in with the multiple choice. And then these guys are a little different. All right. Now we repeated C using a standard deviation from your population, which once we have the population, we have to use a z interval or anything with a z. And what I wanted you to see was the difference between here and here. The rest of it works the same. X bar plus or minus margin of error. So X bar is your mean plus or minus your margin of error. You could see that the T margin of error is slightly larger than the Z margin of error. Why do you think that is slightly larger? T is based on what? Population or sample? T. Sample. So in my sample, and I'm only sampling 10 items here, not a big sample size, right? How do I know that my sample is a very good representation of my population? I don't. So to take up a little bit of slack, it gives you a larger value here because this is exactly the same, just about, pretty close to that. But this is what the major difference is in here. I get a little bit more wiggle room, a little bit more margin of error room in there. So my interval should be a little bit wider for the T. The fact which one would be wider is a great 2-point question. So if I asked you which one would be wider, and you can't remember, you just make up a scenario, put it into T, put it into Z, see which one is wider. Something like this, something like graphing, something that has a little bit more work. Part one might be a good part one question. Is what is the critical value associated with a 90% confidence interval for a z-score, for a t-score? Like something simple but still makes you think. I might give you a couple of things and say, how do you interpret this? If this is what your z-score is, like what is your decision? What is your interpretation? The following data set represents, again, for a sample. Oh, this is the same one. Okay. Sorry, my day is crazy. I did tell you this was t-score also, which I don't know why I did. But this also, you're sampling 8 people. In that same sentence that talks about your random sample of 8 people, it says your mean. So does that mean refer to my population or my sample? Sample. In that same sentence, I say standard deviation. So does that refer to my sample or my population? Ah, come on, think. I'm in one sentence. I'm talking about a random sample of 8 people. And in this random sample, I have a mean of 4744 from my sample and a standard deviation of 580 from my sample. In no way did I end my sentence or say population standard deviation. Assume your incomes are normally distributed and use a T distribution. So again, go to your formula packet under confidence intervals, look up T, and start with your margin of error formula. Or I think I even told you on your calculator, T interval, on your formula sheet, T interval, Z interval, and that. Good. Now, if you use your calculator only, and in your calculator you didn't find your margin of error, all you got to do is take the highest one
and subtract out the mean. And this is your margin of error. Just subtract it out. And there's your margin of error. So can you work yourself backwards in this? Yes. How many of you actually use the test in the calculator? Papa?
I prefer to use
Whatever you prefer to use is fine with me. However, sometimes the answers are slightly rounded differently because your calculator is a lot more exact.
That's gonna matter in the final.
It's going to matter that you say calculator and put in T interval, Z interval, whatever you put in your calculator, I want to see on your paper. Again, I'm afraid that.
And are we gonna get the E equals TC formula?
Yeah, you're getting this on your formula
We're getting
sheet.
all the formulas, right?
Mm-hmm. Same formula sheet that I gave you with your review packet, you're getting on your final.
Nice.
Okay. This guy. Now, how do I know this is a proportion? Because it says, find the point estimate for the population proportion. Proportion, I look up my sheet under confidence interval, and I see proportion. X over N. It's right on there. So X over N. Find your P hat. Find your Q hat. 1 minus that. Construct a 99% or 90% confidence interval for the population for proportion. Remember, when you get these confidence intervals, and this is a great question on your test, when I say this is because I don't know enough about my population proportion. So I'm using my sample to make an inference about the proportion from the population. The reason why we use a margin of error, because it would be really hard to get exactly that point. So my margin of error gives me a little to and from space too, for my population to come into. So remember how we had to say this? I can be 90% confident that my population proportion will fall between these two numbers. Not my sample proportion. I know what my sample proportion is. I know what this is. I want to make an inference about my population based on that point estimate. A point estimate is, again, whatever comes from your sample, because you don't have that information about your population. And with your proportions also comes another minimal sample size. How do I find my sample size? N equals, there's only two things to look at. One has a standard deviation, the other one's got a p-hat in it. So, when I'm on this guy, it's got to be the one with my p-hat in it. This is a little acting up on me today. Find your minimum sample size, that's n. I need to find something that says n equals. So my margin of error is given right inside here, wherever it says within. Within. Find my minimum sample size. Make sure you always round up. Well, in a sample, can I ever get 976.36 people? No. So I need to make at least that much. So if I round it down, I miss that little portion of a person. So I have to round up all the time. Number 24. Number 24 said go back to 19 and do this for the variance. Make a confidence interval for the variance. If you remember your chi-square has a variance. It takes care of the variance. It's always area to the right. A typical 2-point question would be, find me these numbers for chi-square. So on the chi-square, what's going to happen is you're going to have to go to your table 6. You're going to use your degrees of freedom down here. You're going to have to find 2 pieces up here. To do this, it's like your inverse norm, but there's no z-squared for this. So we have to do 1 minus 0.95 divided by 2. So this gives me 0.05 divided by 2 gives me 0.025. Now you're going to find 0.025 and 1 minus 0.025. This is where you find your chi-square from. The smaller one goes on the left, lower one left, larger one right. Greater one to the right. I give you these formulas to use.
I gave you a regular one instead, a confidence interval. But you might find a 2-point question that asks you to find those critical values. Again, remember how bad this looked, but it wasn't that bad. It was your standard deviation. If you had your standard deviation, then don't forget to square it. If you had your variance, then it's already squared. Your degrees of freedom and your critical values from the bottom go in the denominator. But now the thing is, the smaller one goes on the right side, the larger one goes on the left side. Because when we want to divide, we want the smaller number on the left. Should you switch those around, you're going to see that the bigger one would be here. Just don't erase the whole thing. Just flip those two numbers around and make a nice inequality. And from here, just take the square root and find me your confidence interval for your population standard deviation.
Can everybody find those two off of table 6? It's like an inverse norm, but we don't use table 4. We have to use table 6. It says chi-square right on it. So you're going to do the 1 minus that divided by 2, and you're only going to get one tail on that, 0.025. So where's the other one? It's kind of symmetric across your chart. Okay, so here's hypothesis testing. We did this last, so I thought this would be good for you to do this with your multiple choice. There's going to be 3 of them there. One of them you can't use because we didn't do a 2 sample test. But out of the other 2, you could pick one. I'm going to tell you exactly what to give to me. Exactly what we did when we did these. So you find your claim. A citrus grower association believes that the mean utilization of fresh citrus fruits by people in the United States is at least 94 pounds per year. At least is what in a math term?
Greater than
At
no, wait,
least.
at least.
That's the least. Greater than or equal to. Make sure you put the equal sign on that one. That's the HO. The HA is the one without the equal sign.
That's the one that gives you the tail. So I have a right tail test. So now I need to find this cutoff value. I have a sample of 103 people that found the mean to be 93.5. Here's my population standard deviation. At a level of significance of 0.02, can you reject the claim? Is my claim HO? Yep, it's looking pretty good. So now I need to find that critical value. If my level of significance is 0.02, that means this area right here, and make sure you label it correctly. Make sure you label it HO, reject HO. Make sure you label this fail to reject HO.
What you can do if you know hospitals?
What? That's what's crazy on me all day today. Do not know what's going on with my cord. Can you do a p-val? It'll say on the instructions, p-val, or it'll say, I'm not sure what the instructions say. Did this one say do a p-val or a critical value? What did this one say? It said, find it possible, but you did have to identify reject regions.
Appropriate test statistic and possible find the p-value.
Yeah, you also had to find the reject region one too. And if you can, your p-val. The t-square you may not be able to unless you use your calculator for it. So now, finding this guy is just the opposite. Do inverse norm, 0.02. Find me the area, the z-score that's associated with this little piece of area. That's your critical value. This is your test statistic, negative 1.69. This is your critical value, my cutoff. I don't even know what's going on with this. My power board's up there.
Oh.
I didn't even know what was going on with this thing today. You had to see before though.
Standing here.
I was writing like this. You know how sometimes the lines go like,
It's ready to leave just as much as
oh, just as much as me. I keep powering the whole thing off and bringing it back up again. Ah,
This thing today's the last day.
I know.
Going out to fight.
I know, it is going out with a fight. Alright, so now we found our critical value. Tell him I don't want to turn this off yet. Okay, so now, found our critical value, we found our test, show me where it falls. If you found your p-value, you could also do a p-val test against the critical value. Fill it and just label it. Make sure this is your decision. It's going to ask you for a decision. That's your decision. Where you going? So, make sure you give me this. There is not enough evidence at a level of significance of .02 to reject the claim, and spell the claim out. Don't just say claim. Spell the claim out. Basically what we've been doing like the last month and a half is this guy. So I thought that'd be easier for you to do on your first day. An automaker estimates that the mean gas mileage is at least, again, greater than or equal to. We have a left tail test. However, this time, I sample 8 cars. I get in the same sentence the mean, which is from my sample, the standard deviation, which is from my sample. So,
One that like was messed up, right?
I have the T.
Right, but like it was messed up on some of them, right? Because like I did it the way that was written because it didn't say sample. So I did his test.
It didn't? Oh, yeah, this was one of the ones that was messed up, right?
Yeah. So
Yeah.
I actually did.
Right, right. Mm-hmm. Yeah, I don't know how you ended up with different copies of mine. I don't know. Unless I don't know. Unless I changed it on my answer key, but not on my original.
What?
It's pretty good, right? Who's doing this to me? Does anybody have a remote in here for this?
You got
Oh yeah, some phones can be like
Somebody could have the remote to it.
yeah, like all
Is there like
the
an app
stuff
for that?
goes.
Yo, tell me the app.
No, there's a,
Comes automatically.
for this?
Really?
I'm just gonna stop talking.
Wait, there's a remote,
Rebecca,
there's
you
an
know
app
so
for
much.
this?
No, there's
Rebecca, you seem to know a lot
phones
about
that
this.
can.
Yeah, Rebecca.
I have an iPhone, I can't do it. Samsung like Galaxies have like can be a universal remote.
Really?
Oh yeah.
Yeah, I have Natalie like literally like during her classes she turns on and off the TV all the time.
Really?
Really? I didn't know this,
Yeah.
this could go on.
Wait, is it only like
Is it only? Wait, so would it work on my Samsung?
Do you have a Galaxy?
This one? Yes.
Yeah, probably.
Wait, you said it's been doing this all day, right?
No, this part it hasn't been doing, but it's been doing weird things all day long.
I probably should stop talking.
maybe it's
What's the app?
It comes on your phone. I don't know.
Joe. I use that.
Did she talk
Yeah.
about that smart remote thing?
Yeah.
Oh, I thought that's for TVs.
I think it can be like a universal remote. Like it can turn on.
Alright, so are we okay with this? This is basically the same thing, but it's a T. A T one. So you're just using the T formulas. And how do we find the critical value with a T? We look at table 5. Table 5 says one tailed says two tailed. If it's on the left hand side, we're going to have to make that number negative. If it's on the right hand side, it stays positive. That's our cutoff value. We find our test statistic and we test. And we give a decision and an interpretation. This part you should be real familiar with. Now the only thing about this is if it's a two-tailed test. If it's a two-tailed test, remember you got to cut it in half. And then for p-value, you would have to take your p-value and multiply it by 2. But not for the table 5. Table 5, you'd have to use the calculator step. Okay. So, this is a proportion. How do I know this is a proportion?
That's not percentage.
Because it has a percent. What letter does percent begin with? What letter does proportion begin with? Aha, we have a proportion. I also have no standard deviations in this, right? There's no standard deviations in this. So it's either going to be proportion or a chi-square. I know it's not a chi-square because that's my standard deviation one. So can't be there because I'd have a standard deviation there. So again, be careful of this. The only thing you would have to do if you use your calculator is this piece over here. This 0.13 times 57. That's what you need your x value for. You need your x value for that. The rest you can figure out.
Wait, is this the one that you need a calculator for?
You have a calculator step for this.
Which is the one that, like, you can't, that's like...
Chi-square, you can't use a calculator.
Okay.
Matt and Joe, you good with this? I don't remember seeing this on your review. Alright, and the last one is your chi-square one. Your chi-square one, again, uses those formulas. Again, you're looking for your critical value. You're looking for 0.01 divided, 1 minus it divided by 2 first to find out your little pieces. Divided by 2, then 1 minus it. Make sure you get 2 tails. Make sure you come up with 2 tails. Remember on the chi-square, it's area to the right, and there's no negatives. They go from 0 to infinity. So there's no negatives on this. Don't make one of those a negative.
For some reason, I came up with, like, slightly different numbers. Like,
Values, what did you look up in table 6? Because this is a 0.01 and it's 2 tails, you have to divide 0.01 divided by 2 first.
Like, I have the same, like, formula, and I have, like, the same, like, x squared as you, but, like, for the reject numbers, like, I have...
So my point here is you have a level of significance of 0.01. So you have to divide 0.01 divided by 2 first. Because you have to share it. So that's 0.005. So you're looking at 0.005 and 0.995 with degrees of freedom. Did you use your degrees of freedom of 13?
This is like when, like, I did this
Like
first,
you did this a while
so-
ago. Yeah. Yeah, some of you did this first because we just finished this last.
Yeah.
You didn't do it, Joe.
No, I'm saying I understand where you're coming from. Yeah.
Okay, I used 0.01 and 0.99.
That's why. Because you got to take 01 and divide it in half first. Because you didn't have to have 2 tails in that. Yeah. You have to divide that in half first. Okay. I'm pretty sure the chi-square is not part of it, of your hypothesis test. It's probably going to be a z or a t.
There's only going to be one of them.
Well, you'll only have to choose one.
Oh.
There's 2 for you to choose from. It'll either be a z or a t.
Maybe a 2 more after this one.
And
Huh?
A 2 more after this one.
I got rid of those because we didn't do the 2 sample ones.
I feel ready for this. What?
So is this gonna be the test or not?
Where would that look? Ready? Base